Okay, so here's the first example that I want to do for center of weight or center of gravity. And this one states that the rudder of a small boat consists of a stainless steel shaft with 0.8 inch diameter, a circular cross-section, a thin semicircular brass plate, and a thin stainless steel wire. And we are given our specific weights for each of those. Notice the units. The shaft is in volume, inches cubed. The brass plate is by area, inches squared. And last, the wire is by length. The problem then asks us to determine the weight of the rudder and the position of the center of gravity for this thing. Okay, in the Y position only. So we're only going to be looking at how far it is in this direction, right? How far out it is. Okay, so remember, we're looking for our Y bar. And Y bar is again defined as the sum of the Y tilde I for each composite shape, the weight of each composite shape, and then the sum of the individual weights of each composite shape. And it also asked what was the total weight. Again, we're going to use a nice table to solve this type of problem. Okay, so I've drawn the table. You'll see that I've drawn out the three objects. We have the stainless steel shaft, the brass plate, and the wire. What we need to find next is our weight. So I've made that little WI for each individual little weights, and it's in pounds. Remember, our weight is equal to our specific weight times the volume or the length or the area, depending on our density or our specific weight that we have. To find for the stainless steel shaft, we need the volume, right? And volume for a cylinder is pi r squared h times, then again, the density. So that's the formula we're going to use. So again, it's pi r squared. R was given, if you look over here, as 0.4 inches. So 0.4 squared times the overall height or length. In our case, it's 14 inches. And then times the specific weight, which was in this case the 0.284 pounds per inches cubed. So for the stainless steel shaft, that will end up being 2.0 pounds. For the brass plate, we see that it is a semicircular shape, and we're looking for area in this case because our density was pounds per area. The area of a semicircle is pi over 2 times r squared, so pi over 2 r squared. The r in this case you'll see is 6 inches, so it'll be 6 inches squared times the density, and the density was given to be 0.04 pounds per inch squared. And that comes out to 2.26 pounds. Last, we want to find it for the wire, and we need to know the length of that wire. So for a wire, that would be pi r for a semicircular shape of wire times its density, which is, again, in pounds per inch. So be very careful on the units to make sure that they are correct. So this is 6 again, times 0.150 pounds per inch. So then for the stainless steel wire, our weight for that will be 2.83 pounds. If I add up the 2 pounds, the 2.26 and 2.83, I end up with the weight of this whole rudder to be 7.09 pounds. The next step, again, in our formula is to find the numerator, and we need to solve for this y tilde. So we're going to be looking for y tilde I. So this y tilde, again, remember, is the distance to the xz plane. If we look at the xz plane, this is our xz plane. This is our xz plane out here. we notice that this Z axis goes right down the center of that shaft. So for that stainless steel shaft, that distance is 0 because it is right on that plane. Next, we need to find the centroid of the plate itself, the semicircular plate, and its distance to that XZ plane. This is the Y tilde. If we look in the back of the book, we can find that shape, that is this shape, this semicircular shape. And again, this is this 4/3 r over pi is the distance that we're looking for. That is part of it. So let's look at that. Okay, if we look in on the plate, now we see that this is our 4/3 r over pi is this distance here. But that only brings us to the edge of that stainless steel shaft. We need the radius of that shaft, and if you'll recall, that was that 0.4. Okay, so now we can fill in our table with this information. Again, that is these 4, oops, sorry about that. We will have 4/3 times 6 over pi and plus 0.4 inches. Okay, so if we calculate that out, we end up with 2.54 inches. Last, we're going to look at the wire itself. So we need to find out where the centroid of that wire is. We can go in the back of the book and look at what those values are saying. So in the back of the book, if we look at the top, we have this for a arc, and we're looking at this half arc. Here is our centroid for this arc. It is 2r over pi. So we will use that value in calculating our centroid. Okay, so for our stainless steel wire, we know it's out here, and that is this 2r over pi, which brings us to the edge of the stainless steel shaft, and then we need the additional amount of 0.4, which is that radius. That will give us the Y tilde for that brass or stainless steel wire. Okay, so again we use that 2r over pi plus our 0.04. We end up with 3.82 inches. All right, so there, that calculates all of our Y tildes that we need. And then the last part that we need is, of course, our Y tilde i's times each of the different weights. So we can see easily that the first value is 0. The next one we will take our 2.26 times our 2.54. That equals 5.74. And then last we will take our 2.83 times 3.82. And that equals 10.81 is our value for that. So now the last thing we need to do is sum all of these up. This is our the sum of our Y tilde WI's, and that equals, let's see, 18.6 pound inches, and this is pounds. So the last part of our equation is this Y bar. We have 18.6 pound inch divided by 7.09 pounds gives us a value of 2.62 inches. That is equal to our Y bar. So if we look at that, we can see if that makes sense or not. Again, we will erase this, kind of take a look at it. Our Y bar then is out at 2.6 something, not quite 3. So that probably does make kind of sense, right? We have the weight of the stainless steel shaft, which is in more, and the weight of the brass plate more. That might make sense. We're really looking for things that give us something that seems like it's way out here, or negative, or something like that. If we get things like that, then we know we've done something wrong. So this answer seems to make some sense for us. Okay? I hope that helps.